Okay, this is the problem I asked you to save. I wrote save this for later, and it's for right now. So this is the unfamiliar problem. I'm going to walk you through it a little bit, and then you can follow along with me. All right, so given a quadrilateral A, B, and C with vertices -2, 2, all these vertices here, state the coordinates of A prime, B prime, C prime, D prime, the image of the original quadrilateral under a dilation of a factor of 1/2. Then you have to prove that A prime, B prime, C prime, D prime is a parallelogram. So the grid is optional. First of all, we have A, and that's -2, 2. So A prime has a scale factor of 1/2. So you're going to multiply the x and y coordinates by 1/2. So I didn't show any work here, but I took -2 and I multiplied it by 1/2. Those of you that don't have headphones, oh, they're missing out. So if you're wondering if somebody's not wearing headphones and they're confused and just writing this down, it's because I guess I'll write this for them. So the scale factor 1/2 times 8, comma, the scale factor 1/2 times -4. Okay, so maybe that's for them. So this becomes 4 and this becomes -2. Sorry if there have been typos so far. Okay, so this is 6 and -10. And the scaled version is 3 and -5. And D is this one, -4, comma, -4. And the scaled version is -2, -2. Okay, I'm gonna use the grids because I can show you what the image is supposed to look like. So 1, 2, 3, 4, 5, 6, 7, 8. So it's really hard for me to draw straight lines on the screen like this. So bear with me. 1, 2, 3, 4, 5, 6, 7, 8. Okay. 1, 2, 3, 4, 5, 6, 7, 8. So it was hard for me to decide where to draw my axes, but I took a guess considering that a lot of these were negative numbers. I made the third quadrant, really big. Anyway, so let's do 2, -2, 2. Here's A, 8, -4, 1, 2, 3, 4. B, let's do 6, 10, 4, 5, 6. Let's do C, and then D is -4. All right, D. Okay, on top of being nearly impossible to draw straight lines, it's really hard to connect lines like this. Oh boy. Oh goodness. This is not going to go well. Sorry, folks. Okay, all right. So it could be worse. Now, parallelogram. Maybe we're going to prove it. Let's do this in a different color. Let's do 1, -1, A prime, 4, 2, 1, -2. All right, B prime. Let's do C prime, which is 3, -5. 1, 2. Oh, look, a little parallelogram. And this one must be -2. All right, so this looks like a little parallelogram. Oh, but we have to prove it's a parallelogram. Okay, to prove it's a parallelogram, one of the things you need to do is prove slope. So y2 minus y1. That's right, algebra 1, coming back, x2 minus x1. That's right. So you do this between all 4 points. You do this 8 times. Between A and B, D and C. If those are 2 parallel lines, then they're parallel. And then you repeat on with the other side, A and D and B and C. And if that's parallel, then the blue quadrilateral is a parallelogram. So let's see. So you have to see if A, B, whoa, not having that. Okay. You have to see if AB is parallel to DC. So you have to use the coordinates for A. You have to find the slope of AB, which is, oh no, I should have written them down. Oh no, I should have written them down. They're up here. You have to find the slope and you have to check if the slope is equal to D and C. And then you have to take the slope of A and D and see if it's equal to the slope of B and C. And then with the small quadrilateral, you have to see if the slope of A prime B prime is equal to the slope of D prime C prime. And then you have to take the slope of A prime D prime, and then you have to see if it equals the slope of B prime C prime. So they work out. So if you're wondering how to calculate the slope, you take the coordinates x comma y and then the other x comma y. You pick which one's y2, which one's a y1. You pick which one's x2, and you pick which one's the x1, and then you calculate the slope. So for example, this slope is a negative slope. This slope is a positive slope. All right. So just looking at the parallelogram. But that's how you would do this problem. It takes a little bit of time and it's good practice. The biggest takeaway out of all the geometry concepts is being able to multiply the scale factor by each of these coordinates. So if you feel like you can do that, that's good.